Yeah, we saw that training the quantum workforce is quite an important and quite a thrilling topic if we want to stay innovative and if we want to catch up with the quantum revolution. So for the next 40 minutes, we will dive deeper into the topic. We'll talk about successful training and reskilling in the industry, but also in schools. But we will also look at the challenges and hurdles along the way. And it's a pleasure for me to introduce the next moderator to you. It's our own Alexandra Großehold. She's the head of events at Bitkom. The stage is yours, Alexandra. Have fun and have a great conversation. If you want to join the conversation, feel free to use our hashtag QuantumSummit21 and use the chat to engage and ask questions. The stage is yours.
Thank you very much, Kim. Hello and welcome everyone to our panel on quantum education, training the quantum workforce. Before we start, I would also like to invite you to participate via the chat with questions, and I will try to take up as many questions as possible. For this discussion, we have invited 5 experts. The first one is Professor Dr. Bettina. For many years, she managed projects in life insurance companies and specialized on migration projects of life insurance portfolios. Since 2010, she's a professor of mathematics and computer science at THM University of Applied Science. She teaches quantum computing classes and is the coordinator of the Quantum an HAVN network, which is a platform for members of universities of applied sciences to develop teaching inspired by practical applications. Welcome, Bettina. Our next guest is Professor Dr. Raina Muller. Raina Muller is professor for physics education at the Technical University Braunschweig, and he received his PhD in theoretical physics in Constance. He then moved to physics education research for his habilitation on the teaching and learning of quantum physics at LMU Munich. Welcome, Raina. Next one is Clara Neuermeier. Clara Neuermeier heads the business unit executive education of the Fraunhofer Academy. Her business unit organizes over 40 different technical training programs with more than 5,000 participants each year. Clara's scope of responsibility includes the strategical business development, product development, portfolio and stakeholder management with universities and Fraunhofer research institutes. Her major focus is on working on interdisciplinary projects based on the collaboration between multiple Fraunhofer institutes from different areas. Her team and her are responsible for creating new technology-specific trainings and recently also on the topic of quantum computing. Welcome, Clara. Next one is Manfred Rieck. Manfred Rieck is VP Individual Solution Development at DB Systel. He has been with DB Systel since 2013 and taken on the leadership of the Quantum Computing Research Group, in which the industrial suitability of the technology is examined. The group is focusing at security aspects of quantum computing and at optimization problems for logistic companies with quantum computers. He also holds an MBA from the University of Reading, UK, and he is a qualified computer scientist at Rheinische Friedrich Wilhelms University of Bonn. And of course, last but not least, Jan Wender. Jan is a senior expert in the Atos expert community and the Presales organization for the areas of high-performance computing and quantum computing. In this context, he has been involved in the large HPC projects of the data centers in Germany for many years. Since 2016, he is deeply engaged with quantum computing as part of the Atos product and innovation strategy and has given presentations on this topic at numerous conferences. So a warm welcome to every one of you and thank you very much for being here today. Since the time is limited, let's jump directly into our topic. So maybe we'll start with Bettina. So quantum computing and quantum physics have the reputation of being extremely difficult. Where or when should quantum education start?
Yeah, as early as possible, and it has, of course, it has the problem that that quantum computing involves a lot of different materials: mathematics, computer science, physics, all these 3 areas. And I think it should start, in fact, with very little children in the elementary school to give them basic of logical thinking and also to be open for new experiences and so on. And it should continue throughout the whole school, I think.
Yeah,
And then,
Raina,
of course, we have to see how to proceed.
yeah, of course. Raina, how do you see that? And do you know like some principles of good science communication? If we think about teaching already little kids.
Yes, I don't believe in little kids actually. That's more the topic of outreach. But I think it should start at high school. And there one must say quantum computing is not that difficult at all. It is maybe easier than the stuff we are already doing at high school. We are caring for atoms and spectral lines and continuous variables. And quantum computing, mathematically, it's 2x2 matrices or 4x4 matrices and so on. So it can be, there has to be some development of curricular concepts that is tackled now, for example, within the European pilot programs. And I'm quite enthusiastic about teaching quantum computing at high school. That will happen.
Okay, Bettina, from your experience, what basics do students do to understand quantum technologies?
There are a lot of them who are afraid of mathematics because it's in their genes. I don't know, they are afraid of mathematics. And so for the Fachhochschulen, University of Applied Sciences, that's what I'm here in this panel for, is the art is to teach it and using as little as possible requisites, prerequisites from physics and from mathematics.
Okay, so let's try to build also the bridge between academia and industry a
Yes.
bit. So maybe Clara, can you give us some examples for successful training and education in the industry?
Yes, for sure. I mean, in terms of successful trainings, we definitely are in a stage of, or in a really, really early stage. We are just building those trainings up, and we have to find out first what kind of requirements are out there for this technology. Because when I come up from Fraunhofer side, I say this and this and this is important, and maybe everything is on the same level of importance. But for our target groups and for our customers, maybe there are totally different angles of deep dives important. So what we're doing right now is to figure out first what kind of target groups need to know how deep the technology. And we have definitely tech experts here throughout the whole Bitcoin Summit who need really in-depth knowledge and also the combination between the different disciplines. But I think it's really important as well to first, or not to first, but parallel, always to trigger different target groups in the industry, for example, consultants, CEOs, startups, or also innovation management people who are sort of figuring out what kind of potential does this new technology have. So I think this is the first step we have to trigger, to find out first and to sort of at least get a bit more insight what are the actual requirements from those people, to figure then out a modular concept where people can pick the modules they need and maybe not need to go in depth as other people in a team, and then we can work in a team really collaborative and then figure out what's the right training path. So it's not a program, it's more a path where people have to go through and take the models they need.
Thank you. So Manfred, maybe you want to add something, and also I would like to ask, what do you think, which like a kind of specialists do we need? So we do not only need like the hardware and the operating systems, but we also need like people, and as Clara also mentioned, founders, CEOs, for example. How do you see this?
I think we need several perspectives. On one hand, one very successful education program, what we know is from Helsinki, the AI Academy. So within the AI Academy, Helsinki was able to educate 650,000 people, more or less the whole country, on AI. So this is the, let's say, the fundament for everything around AI. And I think we need something like this on the long term in the quantum perspective as well. So we were joking when we came together in this group and said we are some of us are working with Lochkarten some years ago, and others are already digital natives. And I suppose we sometimes need some quantum natives. So it, I suppose, will be the next steps, because it's completely different approach in software development. And so what we need at the moment is experienced software developers, enable them to work with quantum technologies, especially quantum computing at the moment. So they know how to build the software tools at the moment and their software at the moment. And we need some courses, some education for senior developers to get them on track with quantum, because it's more or less completely new for them, and the approaches are completely different. So this is what we've learned during the cloud migration. So we had to change our software development processes to become a cloud native. We changed our more or less the organizations towards DevOps organizations to develop cloud native applications, knowing what containers are. And this is what we need now as well, not only the, let's say, the academic view. I think at the moment, 95% of courses are on an academic. What we need is courses for the industry where we can send our people, our experienced people, to learn basics of quantum computing and then use it as early as possible in real business use cases. So coming out of the academia, going right into the industry.
Maybe if I may answer directly to a few points here. First one, I'd like to object a little bit to your use of the term long term. I don't think we have this much time to get started with education in quantum computing, because, well, this is our perspective. We think in about 2 or 3 years time frame, we will have the first practical uses for quantum computers. So if I am looking to make use of this in my company or in my institute or whatever, I need to get started now. Otherwise, the technology will be there and the other people who have started already will be able to use it. And then in a competition, I will have a disadvantage. So I think we should get started now and should get started with the education now. I agree the education has to be on several dimensions, so to say. We need one educational path for the specialists who need to understand how to program a quantum computer, but I think there also needs to be a bit more of a differentiation. My background is as a computational linguist and not a physicist, so I'm really struggling with these physical properties of quantum systems. And I guess that will be the same for many other people who work in computer programming. Maybe not computer science, but computer programming, which is the large area where computers are used today. And so I think we need to have some kind of second level there. We need to find more abstractions for the actual quantum hardware, put some software layers of abstractions on it, and then we can have an easier interface for computer programmers to make use of this quantum hardware. So that is the specialist path, but also for kind of the general public, what you said about the AI program from Finland was quite interesting. I think we need really to have something similar for quantum computing as well. It is a technology which will change certain aspects of how we are using computers today and in a fundamental way. And that needs to be understood by everyone who is making use of a computer somewhere, and that is basically all of us. Yeah.
Okay, if we go back to the specialists, we have one question from the audience, and then I will come back to you, Bettina. So someone is asking that the impression from this conference, but also from other conferences, that there are significantly less women than men in the field. And so I think it's obvious there's a lack of women. So maybe someone of you wants to answer this question and also give us an idea of how we could help with that.
I think just a quick comment. In my view, in quantum computing, actually, we have more women than in other fields of computing.
Exactly. So this is, I agree. Yes. I agree with Jan. So the deeper you go into the technology, the more women are engaged in this technology. This is very interesting. It's not in the AI. In the AI, it's completely different, but we have a lot of specialized women in quantum computing at the moment.
I think it's interesting, maybe the impression in terms of a quantum summit, like we are here today, who's the person who's speaking actually on the panel. So this might be still maybe pretty male dominated, but from Fraunhofer perspective, for example, I can definitely agree with what Manfred is saying. We have like totally different areas we're working with. We're working with people in the AI sector, but also in the production area or whatever other kind of fields. And this is mainly male dominated. And the quantum team in Fraunhofer, for example, is a really unique team, I think, as it is just a 50-50% ratio right now. And I think it's the first time, actually, it was, in our experience, it's one of the first teams we sort of brought together from totally different kind of fields and from totally different kinds of other backgrounds. Even the gender topic is different. We have a lot of female and male participants in our team, but also from the age difference. We have totally different people coming together on one table. As we have the digital natives, they are really important for this kind of topic, but we also need the people who are working in this area for a really long time and have the knowledge already to bring on the table. So I think it is a chance actually to bring a lot of diverse people together. And I think diverse in every single case. But I think it's still a really important topic to talk about for sure, as we have to sort of figure out who's speaking here today and to engage female people in the MINT area for sure.
Perfect, thank you. Then I will hand over directly to Bettina.
Yes, I perfectly agree with that. It's the same. It's the same at the universities of applied science. Professors are mostly male, but students are half and half, I'd say. And so it's to encourage women to take leading positions. Do it, and to give maybe examples. Why I raised my hand is because I was thinking about the small and little companies in the geographical surroundings of Fachhochschulen. This is one of the strengths of the Fachhochschulen, that they are locally very well connected since decades of years to the enterprises surrounding them, to the companies, and know them very well. And if we go to them and ask, well, how about quantum computing? They'd say, which profit will it bring to me and when? Of course, they think like this. So we have to say, well, at the moment, no profit. And a quantum computer can do only very small things. And so the question is how to get them to our boat. And I think the idea would be to ask them, well, if there was a quantum computer at this moment, a big one, how would it affect your business? Just think about this question for 2 hours. And this is the way one can talk to the management, because time is a rare thing for the small and little enterprises. And before someone comes to have a lecture with us, it's necessary to convince the management of the companies that it will be useful for them.
I think what we could use here is the analogy to artificial intelligence.
Yes.
Neural networks is a technology which was invented in 1950. Then it took quite a long time on the backseat to get developed. And then NVIDIA found out that they could compute these things very well on their GPUs. And then it has an explosive growth. So if you looked at neural networks in like 2010 and started out working with it, you would have a clear advantage using this technology. And I guess that will be the same for quantum computing.
Bettina, I didn't agree completely that this is only a question for the SMEs. I think it's for the large organizations as well. So, for example, in Deutsche Bahn, you know what we are doing usually when we don't have Corona. So we are investing at the moment in this topic because we know that it will come. We don't know exactly when. So Jan says 2 years, others say 5 years. But we know that we need experience in the organization, and we know that it's a kind of experiment, and that this is an investment where you can't calculate a real business case. And this is for large DAX companies, it's not the same. So some large DAX companies are already engaged in the industry group in Jülich. And other DAX companies are completely out of quantum computing because they are working with hydrogen or with new energy approaches, and they are not looking at this new technology. So I agree with you. On the other hand, we need to convince management, so senior management, and this is what Clara said as a target group, to give some education. What does quantum computing or quantum technology really mean? From a computing perspective, from a security perspective, from a sensor perspective, when you look for IoT devices. And I think, so there we need several different levels in the education.
Raina?
Yes, and I also think it's important to build that ecosystem, that broad ecosystem of different specialists we are now heading for. Now the development is driven by physicists, and physicists think like physicists do. We have engineers and information scientists, and we even have a computer linguist here, all bring their perspectives. And we have all followed the development of computers. We are now with quantum in a stage maybe where the first integrated circuits are developed. And at that time in the 70s, nobody would have envisioned the smartphone and Instagram and TikTok and things like that. So we need people with fresh ideas who develop these quantum ideas. There's so much to be found in this area, and I think we just need that ecosystem. And this is a matter of education, generating quantum literacy, making quantum natives is something, some of you said it earlier. We need these people.
So we have so many aspects of quantum education, but I would like to pick up one theme that Manfred mentioned just in a short sentence, and Corona. So I would like to ask you, in general, what are the biggest structural challenges, and maybe are there chances because of the current situation?
So one chance which we use at the moment is exactly this Zoom stuff, this digital option to go into education, into online education, and not classroom education, and learn whatever you find in the internet. So we use online courses from, say, Udemy, Udacity, Coursera, Brilliant, and to learn this stuff. And because what we see at the moment, there is large education stuff in universities, but for, let's say, for senior people, it's difficult to join them because they are in their normal working mode. And so they use their free time, or they get some free time to get into online courses. So this is an advantage, one of the advantages, the only Corona advantage.
Yeah, so that's the one advantage for the not only digital natives, but also for those who are working for long term and those topics. So Clara, you've raised your hand. So
maybe I would add one different aspect as well to add on this. If we think about trainings, it's oftentimes our certain time where we focus on a certain topic we want to learn, and then we go back to our companies, to our old processes, and to our old environment. The chances of digital learning and this new way of learning, how we sort of saw it in the last year, gave us the chance to actually be in their processes, in their life, to actually bring the education programs to them in their environment. We even sort of think, what kind of tools are our customers using? So we bring our trainings in their tools, so we can actually be there for them in a different kind of way. So we think of application, how we can actually apply this whole knowledge to the people on their working desk and stuff like that. I see a chance which makes it different now to think more in a learning journey. So to come back and to sort of consult them for a longer time, or to connect in different times throughout the learning process. And it's not cut after maybe a 2-day training course. So you see, in terms of application, to apply the knowledge, what people learn, a huge potential for the future, and especially if you sort of try to find your knowledge you actually need, because sometimes you're coming for training for a 1 week training, and actually not the whole 5-day training is made for you or for your course. So you can make it more modular, more flexible, and more bringing it more to the people themselves and their problems actually.
Raina, you wanted to add something?
I think that, yes. It's quite amazing what you now see, for example, on the European scale. Within the Quantum Flagship, in the education part, we have created working groups and pilots. And education always was a very national affair, because it occurs in the national language, and it's not so much connected within Europe. But the new possibility of having quick exchanges via video conferences, which just emerged during the last year, has brought a great exchange within Europe with it. And that's a very good development that we can make use of now.
Perfect. And Bettina, I would like to ask you, what do you think are the biggest conceptual challenges? Also, Clara mentioned in a little bit. So in education and training, what has to be considered to make a bigger approach to students?
Yeah, Clara said the word modularity, and I think this is the core concept, to see who needs what, and to tailor things to small units which are self-contained to a little, which are self-contained and which are small and can be put together to give a personalized training to somebody who needs it. And the needs are completely different. We have good experiences with enterprises in the field of quantum sensorics. But here, I think there are material specialists and physicists are working together, and they are closely together from where they come, from their education. Now we are going, at least to me it seems, we are now going in Germany really the step from the physical quantum bit to the logical quantum bit, which means we go the step from physics to computer science. And the challenge is to see who needs what. I think computer science, who wants to applicate quantum computing in computer science, does not need the complete physics. But the question is, what does this person need? And this is a challenge to design these modules.
Yeah, that's very interesting and a big challenge. So within the last 6 months, Germany and the European Union have set up programs like Future Education and QTEdu. Mm-hmm. And what do you think? So who wants first? Is this the right way, the right approach, or should we take another direction?
I mean, I can start in terms of, first of all, I really appreciated that the BMBF saw the potential in how important it is to educate people, to understand what those people who are already experts in are talking about. You know, we have to broaden the understanding in that. So I appreciate that they spend money and they got out this call so early as well. It's untypical, I would say, for us as a research organization. A lot of time we have a lot more research time beforehand, and then afterwards we're thinking about how can we educate people in this area. So I appreciate the timing that it came quite early for German tradition. What I maybe should add, what I think is good or could be even more better, is to, instead of creating a competition between people who are applying for this topic, to encourage, and this was said in the Bitkom Summit a lot of times, to encourage people in getting to know each other and work together closer. I definitely appreciate the encouragement and engagement, for example, from Raina, who sort of tried to put those people together to talk to each other. And this is something what we need to do more often, to collaborate and talk to each other to find out what is the right thing and how we can adjust it. The area is huge. The people are so diverse. The context where we are coming from is so different. Everything is important if we bring it together and if we can combine such a community. And therefore, I think it's good that they sort of invented the module 2 to bring those people even together. But I think it was also really important from the mindset of the people who are actually here today as well, and to engage is important, to be willing to be open to talk about it, to be willing to share what they have in mind and bring together maybe a even bigger part, and not have the competition between us in Germany or even in Europe, being more combined and working together for, in a global perspective, not against other people, but, in a joint force might be more helpful. That's my opinion.
Bettina, do you want to add something?
Yeah, only for short. I'm a very fan of Raina Müller's quantum education landscape, which was done in the European project. And here it's a very good, very shape where one sees what can one know theoretically about quantum sciences, not only quantum computing, but quantum sciences. And it helps so much to position the own position on this landscape. It simplifies discussions. So I want to make some publicity for this quantum landscape.
Thanks a lot. In fact, this is a competence framework we created for the European Commission, which has also made a great effort in education. And it aims to structure the field, as Bettina said. What can you know? What are you able to know in quantum technologies? And that's where we tried to model this competences. I must also agree with Clara. The collaborative spirit in the community is really amazing to see. It's not only in education, although in the scientific areas, where we have really not a spirit of competition, but of collaboration. The competition is not within Germany, it's not within Europe, it's outside China, the US. These are our competitors, maybe. We have to collaborate. I think this is really the message we need to convey. And to answer the original question, I think it's very good to put money into education, because this is really good, well invested money. Everything you put in education, it will come out later. But what one would need more is programs targeted to high school. There are some outreach programs which are addressed to the general public, but they are, the aim is to generate motivation and to generate a good attitude towards quantum technologies. But you really need also programs for high school students that learn something about quantum physics, quantum technologies in school. And these things have to be developed. They are not already there somewhere. They have to be developed. And I think it's possible really to teach quantum physics in high school. And we are in a good position in Germany, because we have the experts, we have the people, we have also well-educated teachers who have had quantum physics during their university studies. These are all things we can use.
So you've mentioned also the programs at high schools, and we have a question from the audience. We've already touched this topic, but again, I would like to address Jan. Someone is also asking about the current challenge to get computer science students into the quantum computing. And maybe Jan, you can share experience, and then Bettina and Raina can maybe give us a view from the academic side.
It's a question from Robert Schade, right? How we can get the computer science students into quantum computing. And well, I agree that we need to do that, and we need to do that quickly. But I'm not that much in touch with computer science students, so I'm not that knowledgeable about their motivations on how to select topics for deeper study. I mean,
so maybe I will hand over to Bettina or Raina.
Motivating factor, it's a future technology which will turn certain things in our technology upside down, and that should generate some interest to work with it in itself, I think, but maybe you can add some perspective on that.
I think that will come. because quantum computing is the new rocket science. It's cool, they like it. And if I, in a course with my students, I tell them, you want to calculate on a quantum computer, and a real quantum computer, there's a possibility, for example, at IBM to make an account and log in and calculate on the real thing, not in a, yeah, they find it amazing, they like it. And I think it's really cool at the moment.
Perfect. So, yeah, no, Bettina,
yeah, if it's okay. We go step by step. There are the normal computer science bachelor and master degree programs. And what we do is we have quantum computing as a facultative course. One can select quantum computing if one wants, and the curious ones come. And then some of them get in fire with the topic and want to continue. And now also in Germany, there are, I know about this, but it's not at the Fachhochschulen, there are programs, master degrees in quantum technologies are being made now. I think that's the way.
Okay, so we have another question. I think, unfortunately, this will also be the last question. It's more about workforce than education, but how can we keep people with those quantum skills in Europe? And what can Europe offer compared to big tech companies in the US and China? So feel free, whoever starts.
I think I can give an answer. So maybe some of you know Jan Götz. He has been in the speech some minutes ago. He's one of the founders of IQM, and he moved over to Helsinki because the environment in Helsinki was much easier to for founding such an organization. They're developing hardware. And so what I see at the moment is that people stay in Germany when the topic is interesting. And what we see as well is these studies are on a very high level. Our universities on a very high level. They are not on a higher level in the US, neither in China. And what we do at the moment is we have the roadmap in place since January this year. So we know what we are doing in terms of quantum computing. And I'm not sure whether we have too few interested students or senior developers. What I see at the moment is more we have too many and we don't have enough offers for them. So what we need is kind of summer school. Maybe Clara, we speak afterwards, what we can do with Fraunhofer. Because I think the place for quantum computing in Germany is at the moment place to be. So when you see what is going on with the alliances at the moment, with money from the BMWI and the BMF, I suppose this is the place where you can do more or less everything in terms of quantum computing.
So thank you very much, Manfred. Unfortunately, the time is already up. And even if we could fill a whole day with the topic, yeah, we have to come to an end. So I think in a summary, it can be emphasized how important it is to tackle the topic together in our network. And I'm also curious to hear more about your collaboration in this group. So I'd like to thank you very much to all of you panelists. Thank you for your time and all the insights. And now I think we can together watch the presentation, which is coming after this panel from Jan. And we are really looking forward to it.
Thank you.
Thank you.